ultra precision alignment isn't actually super critical for our end stop here, but what I am going to do, or what I did do, is I just put the two pins back in their holes and then butted the blade from my square up against the pin, clamped it in place, did the same thing on this one, clamped it in place, and then I set the end of the blade at where I had already pre-marked. I wanted to put the end of my part, so I will back you out a little bit here. So now, as long as I am pushed up against this blade, I am always going to be in perfect alignment with these two pins. I don't have to worry about how well I drew the lines on there. This is the duplicating punch. That's the business end. So this just fits through that 1/4 inch hole. It's a snug fit. There we go. And it's a snug fit on the other hole. So it's time to show you how these duplicating punches work. I'll put the part where I want it. I will set the punch in the hole, part where I want it to be, and now I have perfectly marked the center of the hole from this part. It can't be in the wrong place because this is centered in the hole and that pin is centered on the end of the shank. You could probably make your own set of pins or duplicating punches if you had good blanks, and then ground the end on center. Probably put this in a drill motor and spin it while up against a grinding wheel. You would get pretty darn close. But again, look for duplicating punches, and these are a really handy tool to have. Now I only marked one, so instead of doing both, I could probably get by here. I will put the pin back in the hole, mark this back where it, put it back, and carefully move the pin. There we go. If you have to have super precision alignment, it's best to do one, get it in place, put it where you want it, tighten it down with its fastener with a bolt, and then come back and do the other part. This is not super critical. This is going to be used, I'm going to use hot metal on here, and it really doesn't matter if it's to 1,000th accurate. So we have the two holes marked. We're going to drill these out with a number 7 drill bit, and then we're going to tap them a 1/4 20. And while I'm using some tools that you've never seen before, like the duplicating punch, I'm going to bring out another tool that's very common in industry. This is a drill block, and in the drill block we use slip renewable bushings. These are hardened steel bushings. This particular one is a 1/4 inch in diameter on the inside, 1/2 inch diameter on the outside. The pin is a snug fit down the center of the bushing. And the way I would use this is I would put the bushing in the drill block, center the pin in the hole, and then push it down tight, clamp the drill block in place. And in this case I've got to go over the base, so I open it up big enough, and come on, there we go. Make sure I'm still centered, and when I get this in place and it's clamped down like it is, now no matter what I do, that hole is going to be perfectly centered over the pin, or perfectly centered. So from here I can take a bushing that fits my drill. Now I didn't have a number 7 bushing. A number 7 bushing is, find it here, A 7 is 0.2010, which is the tap size for a quarter 20. What I do have here is a 7/32, which is 0.2187. So this is about 9 thousandths bigger than a 7. For what we're doing, it's going to be perfectly fine. If I was needing to do a precision job, I would then actually go out and get a number 7. But this is clamped down, the block is clamped down, the bushing fits down tight. I will put the drill bit in my drill. Remove the last drill bit I had, put the new one in. Clamp it tight. A little bit of lube. And now I'm going to stay centered and square to that hole. Alright. Pull the bushing out. I don't need this one anymore. I need to drill, I need to tap the hole. And I have a F bushing here, which is a nice slip fit over the tap. So I put the F in, get some lubrication on it, and it keeps me square to the hole, and I can tap that quarter 20 hole no problem. Go in a little bit, come back, break the chips, and you can go back down again. If you try to just screw it straight down, you're going to wind up breaking the tap, and that is not a good thing. You're going to have all kinds of problems. And I can feel it breaking through, so I'm just going to continue. Tap goes all the way through. Again, do yourself a favor, buy good tools. I bought this tap handle when I first started, when I was an apprentice tool maker over 30 years ago. I've got 36 years in the trade, tool making for aircraft. It's still just as good as the day I bought it, and I couldn't replace it today for a quarter of what I spent then. So good tools last you your lifetime. Poor tools, if you're only going to use them once or twice, they may hold up. Beyond that, yeah, they're just not a wise choice. So I'll move back over to the other side here. I will loosen that, remove the drill block, clean my chips off. There's a slight burr there. Let me get a file. I'll clean that up and get the bolt. Okay, I've also gone ahead and reinstalled the scale blade just so that I have a hard surface to butt up against. Take the file, clean the surface so that it doesn't have a burr. I can remount and put the screw in place. And I put when I filed that, I moved the burr slightly down into the hole, so I need to clean that out. That happens, not a big deal. The hole is already there, it's already straight. This isn't going to change anything. And now go ahead, reinstall. I'm just going to go ahead and get a wrench, tighten that down so that we're in a good spot, and then we'll drill the other hole. I've gone ahead and tightened down the bolt. Everything's nice and tight. It's not going anywhere. Yes, I could use the drill block, come back in here and do all that all over again. But before I did all that, we did put a center mark on. So let's just take the dupe bunch and see. Yep, it's still right down the center. So I'm going to walk around to the other side because the camera's right where I normally am. And I am going to drill out this hole. Straight freehand. I'm not going to use anything. I do have to take into account that this plate is leaning a little bit, and that's because it's sitting on things underneath. So I'll take my drill bit, get rid of the excess, come right down the center of my drill hole, and square to the plate. I can feel the drill bit starting to come out the other side. Clearance. Knock the chips out of the way. Little lube on the tap. And again, we're just going to screw this, trying to keep it as square as possible to the surface. Remembering to back out and clear our chips. Quarter 20 when I first started in the tool business a long time ago. Seemed like a really small tap. I broke a bunch of them learning to tap. It's actually not that small. It's one of the really common sizes. Since then I've started working with clocks and stuff, and you want to talk about small screws, they got itty bitty ones in clocks. Finish backing this out, and now the hole is ready to go. We have a tight fit between the screw and the hole, so it's not going to move on us. Let me move over, get the screw, and I'll be right back. Take my rag, clean things up a little bit, make sure there's no chips underneath. Screw and washer, again, I've got to take these screws, cut them down. They're a bit long. They don't need to be anything like that. Anything beyond the bottom of the plate is just wasted, so I'll just cut those off when I get down to the other end. Screw this down until my fingers can't reach it, and put the wrench on. Tighten down tight. See how those washers, I'll move you in a second here. These washers just right up against each other, so I couldn't really go any closer together. There we are. And the end stop is right there ready. There you go. You can see how the washers just touch up against each other. And the end stop. Remove the straight edge. It's right up on our line. It's not going to move. And we have our end of the part for starting our making our bell, which is going to be the end is right against here, so you just put your material in like that. Use your clamp or your vice grips, hold it, and then we will bend around. So the next thing I need to do from here, we need to make the bending tool that will fit on these pins and help us to make our corner bends. While I'm showing you processes that you're not normally going to see that we use commercially in tooling, another one that I do is called doweling, and that's where you take a dowel, and industry standard is that it's the same diameter as the thinnest piece you have, and because these are 1/8 inch angle, we're going to use 1/8 inch diameter dowels. These are hardened steel. They're made just slightly over the diameter. These are 1/8 inch. You use a drill that's slightly undersized, like this, and then you ream it to a 1/2 thou undersize. In this case, we're going to do a number 31 drill. That's 0.120 inches diameter on an 1/8 inch, which is 125. This is a 124.5 thousandths reamer. So we will drill the hole, then we will ream it, and then you tap the dowel pins in. So let me, sorry for kicking you, let me go ahead, I'll chuck up the drill bit, a little bit of cooling fluid, and I'm just going to put this, probably right here. That's a good spot. Try to do this in as few turns of the drill as possible. Remove it, and I'm going to put another one in, probably right there. Okay, so that's about as tight as we can drill that hole. I removed my drill bit, put it back in the drill index, take my reamer out, install the reamer back in the drill, knock the chips out of the way, a little bit of coolant. This we need to do absolutely as few times as possible. And that works. And that works. So from here, we simply take our 2 dowel pins. Let me get the hammer. Hammer and punch. I will take a little bit of compressed air, clean the area up, start my drill drill dowels. I'm only going to use 1/2 inch length. Sorry about that. Let me recenter you. It's kind of hard working right around the tripod. And these should just tap in. Kind of like a nail. And now, no matter what, these details will never move because it's pinned here and here. The bolts are holding it, and it's not going to come out, and that's a permanently located detail. So in industry, after we set our details, always dowel your details. Alright, and it's on now to make the bending handles. I did this with the very scientific ergonomic reasoning of, let's see, this is the longest point that I need to bend, so I'm going to put that there, and I'm going to leave a little bit of room up here for a handle, and that's going to allow me to bring this all the way to 90 degrees. That would be pretty comfortable. So you know what, that's as long as I need it. Material I had laying around, same material we used on the bottom. This is 1 inch by 3/8. Nothing real scientific about it. I did take and can you see that, rounded the end so that there's no sharp edges. Everything's nice and smooth and nothing to catch your hand on. We're going to find the center of these. Do that by, I have a 1/2 inch thick spacer and a block that's taller than that. So I will take and put that here. I will take my 1/2 inch, put it there. I've sharpened my soapstone to a very sharp point. Try to reach over and do this. There we go. We've got down the center. If I need to verify that, I can come on this side, do it again. Now you can see that the line is right there. but I will do it again. So now we know that we're exactly down the center. Anything on that line, do that to the working end of this side also. All we really need is one on the end. So I will take and put this here again, line it up, and make a mark. And so we have center line of those two pieces. So now we need to come in. I need to get my blade back on my square head. Exactly where, doesn't matter. Stick it on there like that. We'll do these one at a time so you can see. All I'm going to do is put the beam on here so that I know I'm square to the side, and push it till it mates, and again come across. I'm now half inch in, half inch in, half inch down. I'm centered on that piece. Come in here the same way, put the square head in, put my spacer in, butt up. I know that it's square, spacer out of the way. Alright, so that is now the center pivot point of both of those. I'm sure there's harder ways to figure out how to do that. That's all we needed to do. I'm going to put center punch marks on those, and then we will go over to the drill press. We will drill a 5/8 diameter hole so that this pin will just slide down the center, and that'll be really nice. That'll give us a nice comfortable thickness of material all the way around, and we'll see you at the drill press. Okay, we've center punched the ends of these. For those of you who haven't seen it, this is called a speed vise. The screw just lifts up, slides back and forth, and then drops back in. There's a taper shape so that it always locks back in. We always want to set our work up so we do not drill into the vise. So I'm going to hang that out just a little bit. I'm going to press it down and tighten it up. That way our work is square. Now I'm going to butt the back of the work up against the drill press, and that way I know that it's not going to spin around. It may still lift up, but it's not going to spin. So I will center up the drill in the hole. The work will pretty much be self-centering. We will start it and put a little bit of cutting fluid on here and go on through. Step it out to a bigger drill. And next one. Okay, I put the next size drill in. This is about as big as this chuck will hold. It's actually slightly larger than its nominal size. But you'll notice that the overall length I can't get down, so I'll drop the table. A little sticky there. And we will come back in. The drill will self-center in the hole when it gets going. Alright, this is not full size yet, but we're getting close. This is actually 545, but we need to go to 625, which is what this reamer is, but we're not big enough yet to allow the reamer in. So I'm going to use a taper seated drill. This replaces the chuck, and this should get us out to 615 or 620. We'll see how well this actually works. Line that back up. Well, that's actually going to work pretty good. So that other drill is a little bit closer than we thought it was. So this is the hole. Get the chips off. This is the bolt. Drops in. Pull it up, and perfect. That's exactly what we wanted. I'm going to do it to the other one. Alright, it's been a couple of days, and I am out in the shop. It's 4 o'clock in the morning, and it's 79.5 degrees out here. It's scheduled to get up over 105 today. The weather's not going to cool down anytime soon, so let's just get this done, get it out of the way. We can get it functional today. There's not very much left. We need to put a pivot, a bending pin on our arms, and a mounting bracket to be able to put it into a post vise, and that's really all it takes to be functional. After that, it's simply a matter of cleaning, painting, inscribing data on it, whatever we need, that we want somebody who's never seen this tool before to know how to use it. So that's all pretty simple. Let's just get this out of the way. What we need to do now is put the pivot in. Let me reach over here. This is our bar. We just got done boring these holes. There you go. See that? That's the pin we just made. We have a nice slip pin. What we need to do is put another pin down here so that this can act as a fulcrum, and then we will have our pin here to form the material. This is 1 inch wide bar. Again, I'm going to be putting a 5/8 bolt just back the other way like this. Screw it up inside, put a nut on the top, cut the top of the bolt off so that it's flush, and then cut the pin down so that I have 3/4 of an inch on the bottom. The way the numbers work out, this is the bar here. Yeah, let me zoom you in here. There we go. That's a little bit better. This is exactly what we've got here. So I need to have a space of 3/4 of an inch between the inside of the two pins. This is going to be a 5/8 bolt. This is which is 625 over here, 312, 312 is half to the centers. So what I'm going to need is this half plus the 750, so that's 312.5 plus 750 is 1 inch. 0625 is the size of the spacer I need to use to go between this point here, the inside of this bolt, to give me the center of the hole that I'm going to be drilling and putting in there for the new bending pin. What I'm going to do is take a device here. This is called an adjustable parallel. This is just because it's so easy to use these. I can slide these back and forth, make it any size I want. There's a couple of set screws on here. So all I do is take a pair of digital, this is a dial caliper, set this to 1 inch, 062, 062, like that. Slide this in here, snug it up, and then tighten the screws. So let me do that, and we will mark off our spaces so we can drill those holes. Okay, I've gone ahead and marked the center line down here, set the adjustable square to just under a 1/2 inch because we have to account for the thickness of our chalk or soapstone, and so you can see that that's the same on both sides. So that's we're down the center. I've set my adjustable parallel to the appropriate distance, so I'll just lift the bolt up, drop that in there, move the adjustable square out to anywhere. It doesn't matter as long as it's big enough to reach across the bar. Then I can come across, lock it, hold it, and we can mark center of our hole. So that's where I need to drill the hole so that I can tap it so that my pin will be in the right spot. I'll get the other one done, put a center punch mark on those, and we will get them drilled out. Okay, let's get this drilled out. This is just a clearance drill here to start with so that I can put the bigger drill in a moment. And we'll change that out to the bigger drill. Okay, there's our tap hole. Let's get the other one to that place. Alright, holes are drilled. Let's get these things tapped. Just like on the bigger plate, we're going to just start the tap with power, and then we'll let the machine come to a stop, and we will then remove it and do it by hand. This time the vise is clamped because these are a much smaller part. Loosen the chuck, and we will finish this up by hand. Another way we can drive this tap right on through, this is a 3/8 socket 8-point, which actually gives me a nice square down the center. That matches the square drive on the end of the ratchet, or the end of the tap here. So I can just drop this on top and power right on through. This is a really big tap. 5/8 are pretty good size. If you're going to do this project yourself, you may want to consider doing this with perhaps 1/2-inch parts. They're a little easier to find tap wrenches for and tooling for. I happen to have a whole bin full of 5/8 bolts, so bigger's better, isn't it? So let's get this tapped. And that's actually a whole lot easier than doing it the way we did it before, or the way I did it before with the big wrench. So now we've got these done. What's this going to look like? I will get my bolt. What I'm going to do is screw this bolt up from one side or the other, really doesn't matter. So I will turn this down so you can see it. I'll run it this way. Going to run this bolt all the way down. Hands are slippery from the cutting fluid. And the threads are a little bit snug. That's not a bad thing. There we go. So I'm going to run that all the way down. We're going to just give it a wrench and give it a little bit of a snug on there. Going to put a nut up from the other side, cut that off flush, and then we're going to come up 3/4 of an inch and cut this off. And that'll be our permanent bend pin, and this will be our pivot. So Presto changeo, best of all worlds. Okay, now moving on to how we're going to mount this plate. I'm looking at it from the top and I'm just deciding where I think it would be a good place to clamp. I'm thinking probably around the center of where we're going to be doing all of our bending would be a good place to put a mount on this. So that's pretty much in line with this first hole. So I'll turn this over. That's the first hole. I just went through my scrap tub, picked up a piece of angle here. This is 1.5 by 1.5 by 4 inches, and that's 1/4 inch thick. Just what was in the scrap tub, not a big deal. So I want it in line with that hole, and I want it running about like that. So that'll just turn so I can get clearance here for my square head. Slide this back just a bit. And something about there gonna work. So that's about where I'm gonna mount it. About like that. This is all just stick your finger in the air and see which way the wind blows. There's no big rhyme or reason to why I'm doing this other than it looks right and it seems like that's what I need to do at that particular time. I am going to arc weld this simply because it's the most expedient way to get it on, and then I do not have any mount bolts or anything sticking through the other side where we're going to be working. So I'm going to run the weld leads over here and we'll go ahead and get this tacked down. It's not going to take a lot of weld either, and then we'll be able to pretty much show you how this works. All I need to do at that point is I've run these bolts all the way down. I'm going to measure up 3/4 of an inch. We'll mark it and then cut that off, and then I can show you how this works. And all that remains after that is just making it pretty. So let me run those leads. Alright, I've left the arc welder in the same settings. We're just going to use the same rod, and this will be pretty quick. Okay, we've left the welder in the same arc settings, so all I'm going to do is just take the same rod and we'll use that to put that angle clip down. Alright, we've got the angle clip mounted on there. Let's just pick it up, drop it into a vise, give it a little snug, get our corner closer to us, give it a little snug, and now we're mounted. Solid table, it's not going anywhere. That's a good thing. We're going to take our pins now. These are the pins that we're going to cut off. I just have a 3/4 inch spacer here. So I'm just going to mark this on one side so that I can see it. Can you see that? That's all I really need. I'm going to mark both of the parts, and then we're going to move over to the bandsaw and we're going to cut these off. Okay, we're going to cut these off, but if I just run these straight through the saw like this, as soon as I get to the back side, what's going to happen, because that is above the center there, as it's just going to pull down and pinch. So to cut this, we're going to need to put it up on a little spacer block of wood. That'll keep me running on a solid flat, and I won't have any problem going through the material. I'm going to lower my guide. You always want to keep your guide pretty close to where you're working. That keeps the blade from twisting. I'll turn my 3-phase on and we'll get these cut. Alright, I'm just going to take these over to the disc sander and we're going to clean these up. And those are going to be our bending pins. A little kiss with a file. Okay, that's 2 done. I'm going to get my mounting bolts. These are still a little bit long, but that's okay. Alright, so when we use these, we want to get the bar back out of the way so that we can have room for the material to stick out. Then we will pick it up, drop it over the stock, bend it. This is already out of the way, so that'll bring the stock over to here. Pick it up, set it down, and bend it until it comes over here. It's the next day and I've decided to come out here and brave the just over 90-degree temps in the shop at the moment. It's coming close to 100 degrees outside. I've cut a 36-inch piece of half-inch square stock, just came out of my scrap tub. It's marked off for a 12-inch bell, so that's 12 inches, and of course 12 inches. I'm going to set this on the jig, and because I'm using propane, I'm going to be able to get one corner at a time, so I will do one corner. I will quench that corner to try to harden it a little bit so that we can get a little bit of tone out of the bell, and then I will do the other corner. We will have the opportunity, because it's square stock, to put twists in the middle for decoration or whatever you want to do. Round stock works, square stock works. The post vise here is not very well anchored down in my normal demo station, so I'm going to move over to the next station that I can actually get a good solid twist on. I don't like just the small little round bases underneath post vices. You need to really be standing on the same piece of real estate that the anvil is attached to. So I'm going to start up the forge. I'm going to move my jig over to a post vise that's not going to move on me. I'll get the material hot and we'll put the first bend in this piece of half-inch material. Alright, I got a good color on here. Let's take this out of the way. Okay, that's the first bend. Quench that down. There's one side. Alright, I've removed the bar, the bending bar, so I can have access here. Bring this in, lock it down. Okay. Hold it like this so you can see it. And we have a nice little 12-inch dinner triangle. Okay, so there we go. This is the result. We have a nice little dinner triangle, 1/2-inch stock, nice 60-degree corners, bent pretty evenly. We have opportunity for a lot of decorative embellishment. You can put twists down the side. You can scribe it with chisel lines. You can do whatever you want to do. The tool is about 95% there. It's got a couple little tweaks to issue or to work out, but other than that, it's ready to go. It's going to be a nice addition to the blacksmith shop in Yosemite, and I think we're there. Thank you very much for watching this video. This is Cal Blacksmith saying get it hot and hit it hard.